Time for a new set of identities, and here we're going to be talking about these two identities called the even identity and the odd identity. And what they have to do with in trigonometry is whether trig functions are even or odd. Okay, and if you remember the definition of even, okay, this definition right here, a function is called even if you plug into a negative value, if you plug a negative x in and get the same as if you had plugged in a positive x. Okay, f of negative x is equal to f of positive x. Whereas odd is a different definition. If you plug a negative value in for x and you get a negative y value, that's an odd function. Okay, and you can think about these in terms of reflections if you're comfortable with graphing transformations. But let's just go ahead and see what happens for cosine of x as this first example. And you'll see I have that one drawn right here. That's the cosine of x. And forgive me my artwork here. You're going to have to fill in with your imagination somewhere. But I want to take a couple points on cosine of x and figure out, using those points, if this is an even or odd function. So here I've labeled some x point right there. Okay. If I look at the negative version of that, okay, which is going to be over here. See, that's where x is just the negative value of the first point. What happened to the y value? Did the y value change? In this case, no. We've got the same exact y value even though x flipped over here. We've got a horizontal reflection, if you prefer to think about it that way. But either way, this is satisfying the definition of an even function. Okay, and you can plot all sorts of other points on this thing, and you would find that every time you look at the negative of one of those x's, you get the same exact y value. It's like y doesn't care whether x is positive or negative. Okay, so this one is called an even function for cosine. Now, if we want to think about that same example with sine functions, well, sines are a little more tricky. Do I have room here? I do not have room. So let's grab this guy and move it up. Okay, I want to explain what's going on here. If you look at any one particular point with this sine function, like this, and then you try to look at the negative x value, well, the negative x value, instead of being right there, is going to be over here, and now we find that the y value is way down here. So obviously y has changed. We can at least say this is not even, but can we say that it's odd? Well, we have to think about this a little more. Let me draw you a horizontal flip. Okay, I'm flipping the whole function horizontally. And you can see that everything that was, I'm not getting this quite right, but I'm basically taking the whole black curve and I'm flipping it over horizontally. But you could also look at this and say, well, wait a minute. This is also a vertical flip. You flipped the whole function vertically. And if you can't tell the difference between a horizontal flip and a vertical flip, that's an odd function right there. What that's saying is, here, let's write it this way. Vertical flip equals horizontal flip. That's what it takes to be. Oh boy, that's spelling. Okay, great. Let's just go with that. Vertical flip equals horizontal flip. A vertical flip is negative times the y value, whereas a horizontal flip is a negative x value. And if those two are equal, then you have an odd function. Okay, and in this graph you can see whether I took that black curve and flipped it upside down or flipped it left to right, it's the same thing either way. So sine is an odd function. And if I start filling in these functions here, you know what, I'm not going to stick to any one color scheme. Let's just fill these things in. Sine is an odd function, okay? So I'm going to write that as negative sine of theta. Cosine is an even function. We talked about that one already. So that's just going to be cosine theta, okay, right? Odd and even. This is all we've talked about. I don't want to get into graphing, tangent, cosecant, and all those, because I have enough information now to fill out the rest of my identities. What is tangent? It's just sine over cosine, right? So tangent of negative theta is going to be sine of negative theta over cosine of negative theta, which, using those first two identities, is negative sine of theta divided by cosine of theta, which is negative tangent of theta. Okay? So you see tangent is odd, like sine. And if we go into cosecant, let's take a look at what cosecant is. Well, cosecant is 1 over sine. That's my reciprocal identity right there. And sine of negative theta is going to be negative sine of theta. And what I just wrote there is negative cosecant. So I can see that cosecant is also odd. And you can use the same arguments on secant. Secant is 1 over cosine. Okay, so 1 over cosine of negative theta. That's just 1 over cosine of theta because cosine itself is even. And that's equal to secant. So secant is even. And you can go through the same argument again with cotangent. I'll just skip to the chase here. That's going to be negative cotangent of theta, which is an odd function. So basically all of these things are odd functions except 2. 2 of them are even. Cosine, and this shouldn't be much of a surprise, secant, because secant is just 1 over cosine. But any function that has sine in it is going to take the odd behavior of sine. All right, and there you go. Those are the even odd identities. So there's 6 of them. There's one identity for each trig function: sine, cosine, tangent, cosecant, secant, and cotangent.